Hi everyone, this is Dr. Nak, and we're going to go over section 7.7, graphs of the tangent, cotangent, secant, cosecant functions. So first, we're going to go over the tangent function. So I've already inserted the graph there. So the tangent graph has vertical asymptotes. So let's go over the properties. So the domain is set of x such that x cannot be a multiples of pi over 2. And the range is all real numbers, and y equals tan of x is an odd function, which means that tangent of negative x equals negative tan of x. We went over that before. And tangent function is periodic with period pi, and the x-intercepts are negative 2 pi, negative pi, 0, pi, and so forth. And y-intercept is only at y equals to 0. Now the vertical asymptotes are at negative 3 pi over 2, negative pi over 2, pi over 2, and so forth. So for the tangent graph, if you look at the one piece of a graph from right to left, tangents start from the right hand side and then it's going to go down towards the left hand side. Let's look at the graph of the cotangent function. Kind of looks similar to the tangent function, but tangent function went from, if you look at the graph from right to left, it started from the right and then it went down towards the left. And the graph of cotangent function is going to start from the left hand side and then go down towards the right hand side. But anyways, let's go with the properties. So the domain is set of x such that x cannot be a multiples of pi. And the range is all real numbers. And cotangent is an odd function. And cotangent is periodic with period pi, just like the tangent. And the x-intercepts are negative 3 pi over 2, negative pi over 2, 0, pi halves, 3 pi over 2, and so forth. And again, y-intercept is only at y equals to 0. And we got the vertical asymptotes at a negative pi, 0, pi, 2 pi, and so forth. Okay, the next one is the graph of cosecant function. So remember that cosecant is just 1 over sine of x. So to graph cosecant of x, first graph sine of x, and at its maximum and minimum point, draw the parabolas either going upward or downward. So do you notice that I have the sine graph in blue right now? So we got, this is our sine graph. This is just one cycle. And this is this point right here will be the maximum. So from that point, you just draw a parabola and make sure that you're going to draw the vertical asymptote at x equals to 0 and at x equals to pi. And then also at the minimum point right here, you're just going to draw the downward looking parabola. And the vertical asymptotes are at pi and 2 pi. So let's just go over the properties of cosecant function. So the domain is set of x such that x cannot be a multiples of pi. And range is either y is going to be greater or equal to 1 or y is going to be less than or equal to 1. Okay, and then cosecant of x is an odd function because sine is an odd function and cosecant is 1 over sine. And cosecant function is periodic with period pi. And there are no x and y intercepts, and the vertical asymptotes are at x equals to negative pi, 0 pi, 2 pi, and so forth. The next one is the graph of secant function. So remember that secant of x is 1 over cosine of x. So to graph y equals secant of x, all you have to do is first graph y equals to cosine of x. Then at the minimum and maximum point, all you have to do is draw the parabolas, just like what you did with the cosecant function. So let me just, let's look at the one cycle of cosine. So it's going to start from 1 and then 0. So let's just look at this piece right here. Okay, so this is up to 2 pi, right? So at the maximum point, all you got to do is draw the parabola looking upward. And at the minimum value, all you have to do is draw the parabola looking downward. Now let's go with the properties of it. So the domain is set of x such that x cannot be a multiples of pi over 2. And the range is again, y is greater or equal to 1. and y is less than or equal to 1. And y equals secant of x is an even function because cosine is an even function and secant is just 1 over cosine. And secant of x is periodic with period pi. And again, there are no x and y intercepts. And the vertical asymptotes are at x equals negative pi halves, pi over 2, 3 pi over 2, 5 pi over 2, and so forth. So on this page, what I did was I just summarized all the graphs that you have to memorize. So all 6 trig functions graphs are listed here. So basically, if you know the sine and cosine function, we just learned how to graph the 1 over sine and 1 over cosine, which is cosecant and secant. But make sure to memorize the tangent and cotangent graph. Remember, the tangent graph starts from the right-hand side of the vertical asymptote, and cotangent starts from the left-hand side of the vertical asymptote. Okay, example time. So example 1, graph and label key points. Find the domain in a range of y equals 3 tan of 4x. So again, this is of the form y equals a tan of omega x. Okay, so let's do the same thing as how we graphed our sine and cosine graphs. So first, let's go with the amplitude. Is what? Absolute value of a. So in this case, it's absolute value of 3, which is 3. All right, and let's go with the period. Okay, now what's the period of tangent? It's pi. So all you have to do is this. If you want to draw just one cycle of the tangent graph, you know that the period is pi. And then all you have to do is insert this argument in between and just solve for x. Divided by 4. Okay, so it looks like our period is going to change to 0 to pi over 4. Okay, we're still going to start from 0. Now instead of a tangent graph ending at pi, it's just going to end at pi over 4, and that is all. Okay, so let's just graph this out, and I'm going to start out with the mother graph. Y equals tan of x. I am so not good at graphing. Okay, so I'm just going to go pi over 2, pi, 3 pi over 2, 2 pi. Alright, so that's pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, and then negative pi. Alright, we got this. Okay, so for the tangent, your asymptotes are going to be at the x equals a multiples of pi over 2. So let me just Alright, I think that's good enough. Okay, so the graph is gonna go like this. Oh my gosh. Actually, that's not too bad. Okay, so now you're gonna have to label the key points. Now the key points are going to be pi over 4 and at negative pi over 4. Okay, at pi over 4, this value right here is going to be 1. And at negative 1. Okay, so let me just, I'm kind of running out of room here, so let me just jot down the key points, and I will write down the key points in red. So the key point right here, sorry, this is going to be pi over 4, comma 1. And then this key point right here is negative pi over 4, comma, negative 1. And of course this point is just 0, 0. Oh, squeeze that in there. Okay, and this point right here is pi, comma, 0. And let me just write this in black here. okay, in between here and here. Okay, so the first thing is what? Pi over 4, 2 pi over 4, which is pi over 2, so this will be what? 3 pi over 4. 4 pi over 4 is pi, so that means this is, oh my goodness, 5 pi over 4. Okay, so now, so this key point right here is 5 pi over 4, comma 1, and, gosh, this is so drawn off the scale, sorry. All right, now this key point right here is going to be 3 pi over 4, comma negative 1. Notice that period is pi because look at this length right here. Let me see. I don't know if you can see that. Anyways, from here to here, what's the distance from here to here? It's going to go from negative pi over 2 to pi over 2, so the period is pi. So from here to here is pi. And also from, I'll just write this on the bottom, from here to here, of course. Distance from here to here is also pi, so the period is pi. Okay, so let me just draw the graph again, directly below. Okay, so what we're gonna do right now is let's try to graph y equals the, what is it? Tan of 4x. And then we'll multiply this by 3 at the end. If I multiply that by 3, all the key points gonna shift upward or downward 3 units, and that's all. Okay, so since the period is what now? Pi over 4. So wherever the pi was, that's gonna become pi over 4. So let me see. Remember the pi was right here. Oops. So this point right here was pi, wasn't it? So instead of a pi, this is just gonna become pi over 4. Okay, so that means what then? This middle dot should be pi over 8. So on this side, you're gonna have negative pi over 8, and then negative pi over 4. So then, so this is 1 pi over 8, 2 pi over 8, and then this is 3 pi over 8, and then 4 pi over 8 is just pi over 2. Okay, and I'm gonna draw the vertical asymptotes. Gosh, I hope you can tell these are vertical asymptotes. My graphing skill is so poor. All right, I think that's pretty good. Okay, so then what? Let's just mimic the graph above. So it's gonna look something like this. That's one cycle. And then here's the second cycle. Okay, so let's make sure that period is pi over 4. So distance from here to here, is it pi over 4? So you go from what, negative pi over 8 to pi over 8. So yes, this period right here, this length I should say, is pi over 4. So it looks good. And from here to here, okay, so you got 3 pi over 8 minus pi over 8. That's what? 2 pi over 8. So that's also pi over 4. Looking good. All right, now let's jot down the key points. Okay, so this middle point right here between 0 to pi over 8, so that's pi over 8 divided by 2, or same thing as pi over 8 multiplying by 1/2. So this point should be, oops, pi over 16. And next one, pi over 8 is same thing as what? 2 pi over 16. So this is 3 pi over 16. 4 pi over 16 is pi over 4. So this is 5 pi over 16. Okay, and this side is going to be negative pi over 16. That's a little pi on the top. Alright, so I think this looks pretty good. So let's jot down the key points. I'll put the key points in red. So this point right here is negative pi over 16 comma negative 1, and then this point right here, oh my gosh, I'm running out of room, sorry, and this is what, pi over 16 comma 1, and of course this is 0 0, and this point is pi over 4 comma 0, and then this point right here is 5 pi over 16 comma 1, and this point right here, I'm running out of room, 3 pi over 16 comma negative 1. Okay, now let's finally draw out what we're looking for. I am completely running out of room here. Alright, so if we want to graph y equals 3 tan of 4x, do you see that key point, negative pi over 16, negative 1, and pi over 16 and 1? That 1 becomes 3, or negative 3, and that's all. Okay, so I still don't want to draw this out again, but I can do it. Okay, hold on. Oh my goodness. Okay, so I'm just gonna draw it out. That's pretty good, isn't it? Okay, so let me just do the same thing. Completely drawn off the scale. Oh my gosh. Alright, so this point right here is going to be negative pi over 16 comma negative 3, and this point right here is going to be pi over 16 comma 3, and this is 0 0, and then this would be same thing, pi over 4 comma 0, and then these points right here, so this one is going to be 3 pi over 16 comma negative 3, and then this point, oh my gosh, this point right there is going to be 5 pi over 16 comma 3. That's all you got to do. Alright, so let's go with the domain and a range. Where can I write the answer? Alright, so let's go with the domain. Domain is going to be settable x values such that, well, you could just write it like this: x cannot equal to negative pi over 8, or where the vertical asymptote, pi over 8, and then what, 3 pi over 8, and yada yada yada. That's good enough for me. And of course the range is going to be all real numbers. Settable x such that x is all real numbers. And there you go. Okay, next example, let's graph and label key points of y equals 3 secant of 1 over 4x, and then boom, minus 1. Okay, so let's first do the same thing, mother graph. Oh, before we do the mother graph, how about we determine the amplitude and the period. Let's go with amp is absolute value of a. Oops, sorry, this is of the form y equals a secant of omega x, and then we're gonna shift all the graph by, shift downward by 1 unit at the very end. Okay, so the amplitude is going to be what? Absolute value of 3, which is 3. Now the period. Okay, so what is the period of secant? Well, secant is 1 over cosine, and what's the period of cosine? That's 2 pi. So secant also has a period of 2 pi. So I'm just gonna go. Now remember what goes in there, right? What goes in there is the argument of the secant. So you're gonna have 1 over 4x. And solving for x, let's just multiply everything through by 4. So it looks like we're gonna have 0 less than or equal to x less than or equal to 8 pi. Okay, so instead of a 2 pi mark, you're gonna have a 8 pi. That's all. Okay, the mother graph. Okay, so first what I'm gonna do is, let me see. I'm gonna graph I think I need to extend this a little longer. First what I'm gonna do is in faint yellow, I'm going to graph y equals the cosine of x. Oh, sorry, so this is 1 and negative 1. And of course this is pi over 2, pi, 3 pi over 2, and then 2 pi. Alright, so the cosine graph, high, 0, low, 0, high. Okay, here's one cycle. Here is the second cycle. Alright, so the one in yellow is y equals the cosine of x. So at the maximum and minimum point, all you gotta do is just flip it. So it looks like we're gonna have vertical asymptotes. Oh, that's a dot. Okay. Oops. Okay, so the one in blue is y equals secant of x. Oh, so mother graph was y equals secant of x. All right, so now the key points are, let me see, let's do that in red. This point is 0, 1. Okay, and then this point right here would be, just going to bring it over here, negative pi comma negative 1. And this point right there would be pi comma negative 1. Okay, so the next step, it doesn't really matter if you want to graph y equals 3 secant of x first or just secant of 1/4 x first. You know what, let's just do the secant of 1/4 x. Oops. Oops. Let me just go with, so do you see what's going to happen if I multiply that by 3? The negative 1s and 1s just going to become 3 or negative 3, that's all. Okay, but anyways, let me just deal with the period first. So here you're going to have secant of 1/4 x. Okay, so I'm going to try to draw the same, the graph right directly below. So I'm just going to go like this. And then oh man. Okay, so let me just go with, okay, looking good. Okay, so period, it was from 0 to 2 pi, but that changed to 0 to 8 pi. So where the 2 pi was becomes the 8 pi, and that's all. Okay, so the middle part should be 4 pi, right? So that's 2 pi, 4 pi, 6 pi, it looks like. And then negative 2 pi, negative 4 pi, negative 6 pi, and then negative 8 pi. Okay, so let's draw the same vertical asymptote on the same spots. Okay, and then just draw the very similar picture. Oops, sorry. So this was what, 1, and this was -1. So I'm just gonna now draw the secant graph. So here, okay, now key points. So it looks like this point right here, it's going to be -4 pi comma -1, and this is still 0 comma 1, and this point right here is 4 pi comma -1. Almost done. So I think this was the hardest part for me, at least. Okay, so now let's go with, okay, y equals 3 secant of 1 over 4x. Okay, so all you have to do is change the 1 and -1 to 3 and -3. That's all you got to do. So let me just draw that out. Why did I put that in black? Okay, I mean blue, sorry. I need to put that in black. Okay. Okay, and then my grid is so off. So it's 8 pi, 6 pi, 4 pi, 2 pi, -2 pi, -4 pi, -6 pi, and then -8 pi. Okay, we got this. Okay, so instead of 1, this guy is going to become just 3 and -3. Okay, and we just draw the same darn graph. All right, so from here, uh-oh, I'm running out of room again. There you go. And then from here, like this, and then from here, like that. Okay, so the key points. So you got 0 comma 3, and this point is -4 pi comma -3, and this one is 4 pi comma -3. Okay, we're almost done. So the final graph, y equals, what is that, 3 secant of 1/4 x and then -1. All you have to do is take the graph above, and for the y value, all you have to do is just subtract 1 from it, because you're going to be shifting 1 unit downward. So my goodness, I'm running out of room. Okay. I may not even able to draw this in the right way. Okay, but okay, so instead of 0 comma 3, it's just gonna become 0 comma 2. So shoot, let me just do this one first. Okay, so the key points, just shift the y unit, y value, subtract 1 from it. So shoot. So this point right here is just going to become 0 comma 2, and then this point right here is just going to become -4 pi comma -4, and then this point here, just bring it over here, it's going to be what is it, 4 pi comma -4. That's the only difference. So let's go like that. I'm sorry, you guys. I'm running out of room everywhere, but you got the point, right? I hope. And it goes like that. All right, we can do this. Okay, so let's just go with the domain. Is settable x value such that, now look for the vertical asymptotes. The vertical asymptotes, what? X cannot be negative 6 pi, negative 2 pi, 2 pi, 6 pi, and yada yada yada. That's good enough. And the range? Okay, so let's go with the range. So range is settable y values such that all the y values are either going to be greater or equal to 2, or all the values of y's are less than or equal to negative 4. And that's our answer. Good job, you guys. I know that graphing is so tedious, but I hope you understood what we just went over. And be patient when you do these kind of problems. It takes me a long time to do as well. So do not get discouraged, because you can do it. If I can do it, you can do it.